Okay, howdy sports fans, Mr. Nelson here. Today, it's always exciting when we start a new topic, concept, it's fresh, it's new. We're starting a pretty cool one in Quadratics, a pretty involved unit. And Quadratics essentially just revolves around, to simplify it, equations that have a square in them. Okay, so linear equations of the form y is equal to mx plus b. There's no squares in here. It's linear. X has got one power. Quadratics introduce the y is equal to x squared. This is our baseline quadratic of the form. It looks like, in its simplest form, wow, terrible. In its simplest form, it looks like this. It just does a u, boom. And its vertex, or its lowest point, is at the origin. If I put a negative here, basically it just flips it upside down. Okay, so we're going to talk all about these things. This would be considered, right here, this would be considered our kind of, our original quadratic equation, our baseline quadratic equation, and this is in this form, it's in general form, essentially. General form. Now, we can rewrite this equation in the form like this, and it's going to be the exact same. X minus 0 squared plus 0. Okay? This is standard form. In standard form, in more general terms, general standard, more vertex form, vertex standard, vertex are the same thing, different words for the same thing. But if we write our standard equation for this particular quadratic in general form, it would look like this. And I'm going to use a different color for this. It's special, super special. It would look like this. Y is equal to a x minus p squared plus q. Okay? I've introduced 3 different letters. And we learned the standard form because it's a form in which these different letters have significance and they do things for us and they tell us things about our quadratic. So I'm going to put our kind of our general x is equal, y is equal to x squared quadratic right here. It's not going to be symmetrical, but you can imagine it should be symmetrical. It's symmetrical around the origin and the y-axis right here. So what do each of these things tell us? Well, the things that we'd like to know about a quadratic curve are things like its vertex, so its maximum or minimum curvature point, so this would be a vertex here. Its vertex, its axis of symmetry, I'm just going to say A of S, axis of symmetry. We can learn about shifts horizontally from the original here, so from the origin, shifts horizontally, shifts vertically. We can also figure out our y-intercept from this equation. Just our y-intercept occurs when x is equal to 0. So if I put 0 in for x here, knowing these other numbers, that would give me a corresponding y value at x is equal to 0, which would be my y-intercept, but we'll get to that. So these are the things that these letters can tell me. And I can also know whether my curve has been compressed, so kind of made thinner, so compressed like this, or expanded like this, okay? And that's what this little a here is going to tell me. Compressed or expanded. And I might be forgetting something right now, but hopefully I'll remember as we go through. So, what does the a tell us here? So if I have an equation that looks like y is equal to 2x minus 1 squared plus 2. for example. This too, A, is A, okay? Now, A, if it's positive, the quadratic, the graph is going to open like a smile. It's happy, it's positive. Opens upwards. If it's negative, it's sad. It's frowning. So this would be a negative x squared, right? Frowning. Opens downwards. Okay? And so that's just the sign itself. In this case, we're positive 2, so we know that we're going to open up. That's just the sign. There's also the number that we need to consider, okay? Now, if A is greater than 1, so if it's 2, 3, anything bigger than 1, we're actually compressing our quadratic graph. So we're pushing it thinner. If it's greater than 1, so in this case, we're going to be compressing it. Greater than 1, compression. And if it was, say, -2, well, -2 would look something like this. We're compressing it, but we're still sad. We're still sad. Okay, compression. And then what if A is a fraction? It's between 0 and 1. Okay, it's a fraction. Well, in that case, we're going to get expansion. So if I had y, for example, instead of +2, I had y is equal to 1/2. Okay, this would look more like this expansion there. If it was a -1/2, it would look more like this. Okay? That is what A tells us. That's the importance of A. Okay? I'm going to erase this. So, take a moment with it. I'm going to erase. Okay, so that's A. P. What does P tell us? Well, P tells us quite a few things. A couple things for sure. So if I have, again, an equation of y is equal to 2, for example, -2 squared plus 3. Okay? In this case, P is going to be equal to, basically, this is the trick here. P is going to be equal to whatever this number, but the opposite sign of whatever sign it's sitting in here with. Because this is the same as saying x minus +2. Okay? The minus is always there, but in this case it becomes one big negative. So we have to know this little trick, and the easiest thing to do is just to take the opposite sign. If there's only one sign, just to take the opposite of it for the value of P. Okay, so let me repeat. You take the opposite sign of P, because this should be x minus a +2, but they're just simplifying and saying x minus 2. So the P in this case is +2. If I had x plus 2, well, that would be the same as x minus -2, which means that my P is now negative. So you take the opposite sign for P. Okay, so let's stick with what we were doing. Now P is both a coordinate, so it's a coordinate, the x coordinate of our vertex, so our lowest or highest point in our curve, depending on whether it's frowning or smiling. And it is also the axis of symmetry. So here, the axis of symmetry would occur at x is equal to 0, and x is equal to 0 is also the coordinate of one of the coordinates of the graph here. That is P. One more thing that P does is, if P is positive, it means that it's talking about the horizontal shift. Horizontal shift. So say I didn't have any Q here, but it was just a simple x minus 2 squared. In this case, P is 2. This would tell me that I am basically just moving my original x squared curve, but I'm shifting it over two spots. So this would be x is equal to 2. So now my axis of symmetry is at x is equal to 2, so the horizontal shift. If this was a positive 2, giving me a negative p, I would just be shifting 2 to the left, or towards negative. So my new axis of symmetry would be at x is equal to negative 2. So the p is our horizontal shift, our axis of symmetry, and the x-coordinate of our vertex. Finally, go back to our original, we'll just say 2 plus 3, I think it was. Okay, so finally, q, this number here, just sitting on its lonely, q is, it's the straight number. So in this case, it's positive 3. There's no switch around it. And q is the y-coordinate of vertex. It is also the vertical shift. Vertical shift of our graph here. Now it's getting a little bit messy here, but let's imagine that I'm going to stick with I'll take away the 2 here just to make it easier. And you know what, I will just erase this because it's getting a little messy, and I'll redraw it. So from this, and let's keep the 2 here just to keep it interesting. I have my original y is equal to x squared, okay? This is y is equal to x squared. Now if I look at this, this tells me everything I need to know, okay? So vertex, I can look at this and be like, okay, I'm getting ahead of myself. Let me finish this here. So if I had 2x minus 2, so that's p is 2, so I know that my vertex is going to occur at positive 2 and positive 3. So this is where the vertical shift happens. I'm moving up 3. So my new vertex occurs at PQ. And because it's also compressed, it's probably going to look a little bit more like this. It's a little bit more, it's coming a bit. Okay? That's what my new chart would look like. Okay? It goes on to infinity. And so I could take this and go right here and be like, okay, right off the bat I know that my vertex is PQ, so it is positive 2, 3. And then I know that my axis of symmetry occurs around the P. So it occurs at x is equal to P, so my axis of symmetry is x is equal to 2. I have a shift horizontally 2 to the right, or to the more positive. I have a shift vertically 3 up. My y-intercept for this one will occur when x is equal to 0. I can't really tell from here, so I'll have to actually do a little bit of math to figure that out. So I go y is equal to 2, 0 minus 2 squared plus 3. Y is equal to 2 times 4 minus 2 squared is 4 plus 3. Y is equal to 11. Okay, so that's my y-intercept, because that occurred when x was equal to 0. So my y-intercept is y is equal to 11 at x is equal to 0, which makes it intercept, and I am compressed by a factor of 2, which is the A right there. And that is why we learn standard form. The next level up is learning our general form. So being able to take an equation that looks like y is equal to ax squared plus bx plus c, and being able to take this and convert it into standard form so that we can pull off all these things. And we're going to learn how to do that with something called completing the square. But hopefully this has kind of shed a little bit of light. There's a great website if you want to do some graphing of your own. It's called www.desmos.com, D-E-S-M-O-S. It's got a free graphing calculator. Really good to just play with different things and to see what kind of curves they make. But that's all for today. Thank you for watching.